Hello everyone, welcome to series lectures of basic electronics. Today we are going to discuss about new chapter which is special purpose diode and transistors. Today we are going to discuss about special purpose diode part 1. So in this series we are going to discuss about various types of diode and its application and its construction with working principle. So today's outcomes are, here we can see these are the today's outcomes. First, we will discuss about Zener Diode, then after its symbol and working principle and characteristics. The next diode is LED, which is also known as light emitting diode. In LED, we are going to discuss about construction, working principle, pros and cons with applications. And last, we will discuss about Varactor diode. In Varactor diode, we are discussing about working principle, equivalent circuit and its application. So don't waste time, let us start with Zener Diode. So here we can see Zener Diode. Normal PN junction diode, if we adding impurities, that becomes Zener Diode. A heavily doped semiconductor diode which is designed to operate in reverse bias direction is known as Zener Diode. In other words, the diode which is specially designed for optimizing the breakdown region is known as Zener Diode. Here we can see this is the symbol of Zener Diode. So anode and cathode, current always flowing from anode to cathode. So this is the symbol and this one is the actual appearance of Zener Diode. So here we can see at plus side, at anode side, current always flowing from anode to cathode. Here, at this terminal. So if you have an actual Zener diode, how to indicate and how to identify that leg is anode or cathode? If there is a black lines, that is cathode. Here we can see in actual appearance of Zener Diode. So now let us discuss about Zener Diode. It is work in both bias. It is in forward bias or it can work in reverse bias as well. If it is working in forward bias, then it behaves like a PN junction diode. If it is in reverse bias, then it works as a voltage regulator. So this is the main application of Zener Diode, voltage regulator. So in this topic we are going to discuss about thoroughly a voltage regulator. So here we can see this is the circuit diagram of voltage regulator. In this circuit diagram, V in indicates input voltage. We are going to enter unregulated DC at this side. Then after this side V output, we will get output voltage across the load resistor RL, and here parallel to RL is connected VZ, that means Zener Diode, and across that we will get Zener voltage. So here we can see the term regulator means which regulates. Now here we have to regulate the voltage V out. It should be constant. Now how it remains constant? So for that we have to explain this phenomena. Here we can see if IL remains constant, IL that means load current, if it remains constant and VI increases, VI that means input voltage, if input voltage increases, so output voltage VO tries to increase. If VI increases, then VO tries to increases. But Zener Diode takes more current, thus IS increases. Here we can see IZ, that indicates Zener current. At this time, it consumes more current, so IS increases. If IS increases, that means across this resistor resistor RS, voltage drop, that means VRS, we can say VRS is equal to IS into RS. Voltage drop is increases and VO does not increase, that means it remains constant. Because here we can see across this RS, the voltage drop increases. So due to this, here V output is not increasing. That means it remains constant. And next possibility, if IL remains constant but your input voltage Vi decreases, so VO tries to decreases, but Zener diode takes less current, thus IC decreases. IC decreases, that means across this voltage drop is going to reduce. Voltage drop is reduced, that means your VO does not decrease, that means it remains same. So like this, it regulates this voltage. The output across the diode will be constant. So here is the explanation how Zener diode works as a voltage regulator. Now in this graph, we will discuss about VI characteristics of Zener diode. Specifically, Zener diode is used for reverse bias. Here we can see this is the characteristics of forward bias. As we discussed earlier in PN junction diode, if you increase voltage at this time, your current is gradually increased, but after 0.7 voltage. So here we can see this is the VI characteristics for forward bias. Then next, here we can see this is the VI characteristics for reverse bias. Now this is the knee point where your graph is going to be bent. Here we can see this is the reverse current, which is known as IO. This is known as Zener voltage VZ, and at this point we can say it is IZ minimum. At this point your Zener current is minimum and gradually it is going to be increased like this here. This is known as IZ maximum, and this region IZ minimum to IZ maximum is known as Zener region. Here we can see this is the Zener region. Let us discuss about LED construction and its working principle. First, construction. There are two leads. First lead is long, which is known as anode, and another lead is short, which is known as cathode. That means anode is positive and cathode is negative. Here, LED, we have seen different types of semiconductor materials are used for various light effects. For example, GaAs, gallium arsenide, GaAsP, gallium arsenide phosphide, GaP, gallium phosphide, etc. Because we want few different lights. Like if you are using GaAs material, then you will get infrared light. If you are using GaAsP, then you will get red light. If you are using GaP, then you will get green light. So this material indicates its light, and SiC indicates white light. So according to your application, you can use different types of material. Now let us discuss about working principle. LED mostly working in forward bias. Now here we can see due to forward bias, electron go from the conduction band to valence band and recombine with the hole. There are different types of band. One is valence band, which is known as lower band, and another one is conduction band, which is higher band. Electron is in ideal condition. If it gets energy, then it will be free from that portion, free from that valence band, and goes to the conduction band. In conduction band, it moves and collides with the other electrons, and after that it recombines with the hole. If it recombines with the hole during this time, the light is emitted through this LED. So this is the main working principle. Now there are three types of layer. First one is P layer, then active layer, and then N layer. P layer is above layer, then after this active layer, and then after N layer. Here we have to remember that P layer should be above, because recombination process is doing in P layer. That's why light is emitted from this layer. So we can understand easily from this construction. Here we can see in this construction, first is a reflective cap which is transparent, and from this cap we will see the light. Then after, in green surface, we can see this is the P layer, where we can see the recombination process, and due to this recombination process we will get light. Then after, one region is there which is known as active layer, and then below is N layer. Above this reflective cap, one blue area which indicates positive terminal, and below negative terminal. So positive terminal and negative terminal, if we connect with the battery, light is emitted from this reflective cap. So this is the construction of light emitting diode. And here we can see this is the symbol of LED. Basically this is the PN junction diode, but here we have to mention this arrow indication. That indicates light is emitted from this diode. So that means this is the light emitting diode. And this is the actual appearance of LED. This is the lens, red color indicates the lens. Below that, semiconductor material and two leads. One is anode and another short is cathode. Now let us discuss about its advantage, disadvantage, and its application. First advantage, it has long life. It can be operated at low voltages and switching is fast. So these are the advantages of LED. And disadvantages, display becomes dim in the ambient light, and power consumption is more compared to the LCD display. So these are the disadvantages of LED. And applications, that means where we can use it in large numerical displays, or we can use also in optical communications, or we can say it is also used to display alphanumerical bits. So next special purpose diode is Varactor diode. Varactor diode is different among these two, LED and Zener diode. Why? Because it works in only reverse bias. Here we can see it is also known as Varicap and voltage variable capacitor diode. So here we can see this is the symbol of Varactor diode. Now what is Varactor diode and how it is working? So first, in unbiased condition, if there is a depletion region, then after, if we bias it should be in reverse bias. If we increase this reverse bias, then its depletion region width is also increased. So its depletion region behaves like an insulator. Both the side is known as positive charge and negative charge. Here we can see junction capacitor is formed. So depletion region is equivalent to the junction capacitance. Diode is connected in reverse bias. The depletion region width is increased. With increase in reverse voltage. Thus, Varactor diodes is reverse biased, whose junction capacitance can be varied by varying the reverse voltage. Here its equation will be C is equal to, that means capacitance, transition capacitance, we can say CT is equal to epsilon A upon W. Or we can say C is directly proportional to the A upon D, where C is the capacitance, A is the area of plates, and D, that means distance between two conducting plates. So this is the Varactor diode. Now here we can see this is the equivalent circuit of Varactor diode. Actually here we can see the capacitor is cited, but that is Varactor diode. Because with the depletion region, we can say that it behaves like as an insulator. So this is the equivalent circuit of Varactor diode. Here we can see applications of it. It is used in frequency modulation circuits. It is also used in voltage tuning by changing reverse voltage capacitance is changed. So the result frequency is changed. So this is the Varactor diode. Now that's all for today's about special purpose diode. Till then, keep reading, keep learning. See you soon in next part. Thank you.